We're on lesson 3 of chapter 6, which is to solve linear systems by adding or subtracting. First, we're going to add or subtract to eliminate variables. Then we'll arrange like terms to solve. Then we'll write and solve a linear system. We've already learned a little bit about substitution to solve things. Sometimes there is an easier way. For example, when you have two equations that are like this in a system, we have 3y plus 2x equals 13 and 4y minus 2x equals 15. By adding the y's and the x's and the constants together, sometimes we can eliminate a variable. So for example, we have positive 2, we have negative 2. I know that positive 2 plus negative 2 would be 0. I can eliminate the x's out of this whole system. So let's do that. If I add everything together, 3y plus 4y would be 7y. Then I would have 0x, or just nothing, right? Then the equal sign, and then 13 plus 15 is 28. Now I have 7y equals 28. I can divide both sides by 7. Therefore, y equals 4. Now that I know y, we know this step, we can just plug in the 4 for y and then solve for x. So to do that quickly, 4 times 3 is 12. So 12 plus 1 would be 13. So 1 half times 2 would be 1. So x would be 1 half. So my answer would be 0.5 and 4 for my coordinate. So adding and subtracting is a very viable method. Let's take a look. It says to solve this linear system, 2x plus 3y equals 11. Negative 2x plus 5y equals 13. Here I see that positive and negative again. I can get rid of those x's. So if we add these together, we can get 2x minus 2x, which would be 0, 3y plus 5y, which would be 8y, and then 11 and 13 would be 24. Divide both sides by 8, and therefore y equals 3. And I could plug this 3 in for either equation, whichever one looks easier. I like the ones without the negatives, so we'll do that. So we could have 2x plus 3 times 3 equals 11. So 2x plus 9 equals 11. Subtract that 9. So therefore 2x equals 2. Divide both sides by 2. Therefore x equals 1. So I know that y equals 3, x equals 1. I can make my point as 1 and 3. Great way to solve that. Now I have 4x plus 3y equals 2. I have 5x plus 3y equals negative 2. I have two positive 3y's. Well, I know that positive 3 minus positive 3 would be 0. So I can eliminate the y's here. So let's subtract both sides of this equation then. If I do 4 minus 5, that would be negative 1. So negative 1x. And then the 3's would cancel out by subtraction. And therefore I would get 2 minus negative 2, which would be like adding 2, right? So it would turn into positive 4. Negative 1x equals positive 4. Divide both sides by negative 1. Therefore, x equals negative 4. So I have my x value. X equals negative 4. Now let's find my y value by using either one of these. Let's use this one right here. So we have 4x plus 3y equals 2. Plug in that negative 4 for x. So 4 times negative 4 plus 3y equals 2. 4 times negative 4 is negative 16 plus 3y equals 2. Add the 16's to both sides. Therefore, I would have, I'm going to write this over here, I would have 3y equals 18. Divide both sides by 3. Therefore, y would equal 6. Then if I write my coordinate point, it would be negative 4 and 6 for my answer to this system. Now we can arrange like terms to solve, meaning that it's not always going to be neatly lined up for you with the x's lined up perfectly or the y's lined up perfectly. Sometimes we have to do some rearranging. Here we have 8x minus 4y equals negative 4. Here we have 4y equals 3x plus 14. So if I made this one look like that one by moving this 3x over here on this side, I can make these terms line up. So let's do that. I have 8x minus 4y equals negative 4. By subtracting 3x from both sides, I would have negative 3x plus 4y equals 14. And now I have a negative 4y and a positive 4y. Well, if I add -4 and +4, that would give me 0. So we're going to be adding on this one. 8 plus -3 would be 5x. Then I have nothing for the y's, and that equals -4 plus 14 would be 10. Divide both sides by 5. That would give me x equals 2. So now that I know that x equals 2, I can plug in that 2 for x. Let's use the one without the negatives again. So we would have 4y equals 3 times 2, because x is 2, plus 14. So 4y equals 6 plus 14. 4y equals 20. Divide both sides by 4. So therefore y equals 5. So x equals 2, y equals 5. And if I write this as a coordinate point, it would be 2 and 5. And that would be the answer to this system. Let's write and solve a linear system then. It says during a kayak trip, a kayaker travels 12 miles upstream or against the current, and then 12 miles downstream or with the current, as shown here. The speed of the current remained constant throughout the trip. Find the average speed of the kayak in still water and the speed of the current. We need to know the speed of the kayaks heading upstream and downstream in order to make this work. Remember, speed is the distance traveled over time. So 12 miles divided by 3 hours. 12 divided by 3 would be 4. So 4 miles per hour upstream. And then 12 miles in 2 hours would be 6 miles per hour downstream. We don't know the speed of the kayak in still water. We also don't know the speed of the current. But I do know that the speed of the kayak in still water minus the speed of the current, which it could be y, equals 4 miles per hour. That would be the upstream one. The speed of the kayak minus the speed of the current equals 4. Then I also know that the speed of the kayak plus the speed of the current equals 6, because that's how fast we're going downstream. So by solving this linear system, we can get this figured out. I could either subtract the x's away or add the y's away. I'm going to choose the add the y's away. So x plus x would be 2x. Then negative y plus y would be 0y, or just nothing, equals 10. Divide both sides by 2. 10 divided by 2 is 5, so therefore x equals 5. Remember what this was? This was the speed of our kayak. So the speed of the kayak is 5 miles per hour. Now that we can plug this in, we can find out the speed of the current. So let's plug it into the second one. So x plus y equals 6, so 5 plus y equals 6. Subtract 5 from both sides. Therefore y equals 1. So therefore we have x equals 5, y equals 1. Then we can write this out as a point as 5 and 1. Then to write this as terms, we would say speed of the boat, or speed of the kayak, 5 miles per hour. Speed of the current would be 1 miles per hour.